Hi everyone, welcome to my channel. In this mini series, we are going to learn how to work with Spring and Cassandra. We will focus more on the Spring side from the Java code perspective, but we will still cover the basics of Cassandra. This is going to be a 3-part series, and by the end of this series, you will have sufficient knowledge to explore this space on your own. So let's get started and let's discuss the agenda. Talking about the agenda, we'll start with a brief overview of Cassandra. Then we'll discuss the powerful combination of Spring and Cassandra, why Spring and Cassandra. After that, we'll see how to set up Cassandra on our local machine. And once that's done, we'll start working with a Spring Boot project. We'll set it up and we'll see how to connect to Cassandra using Spring Boot project. So let's start. What is Cassandra? Cassandra is basically a NoSQL database management system. It's an open source project. Cassandra is a distributed, decentralized, and highly available data store. We will discuss these keywords when we discuss the key features of Cassandra. It was initially developed at Facebook, later it was donated to Apache Software Foundation, and it is now being maintained as an Apache project. On the right hand side, you see a logical representation of a Cassandra cluster, which looks like a ring. In this ring, there are nodes or machines which are connected to each other, and they all are talking to each other. And each node can store some data, and it is basically storing a range of data. Moving on to the use cases, Cassandra is designed to handle vast amounts of data, big data, offering high availability and fault tolerance, which makes it an excellent choice for applications that require continuous operation and uninterrupted performance. So if your application is write heavy, then it could be a right candidate for Cassandra. And so Cassandra can be used in IoT applications. It supports time series data. It can also be used to develop big data solutions. Cassandra can be used to run analytics. It is used in messaging and chat applications, recommendation engines, and so on. Moving on to key features of Cassandra. Cassandra is a distributed and decentralized data store or database management system. Distributed means that Cassandra is capable of running on multiple machines. It can scale to millions of nodes. For the user or for the client applications, it will look like a single system, but under the hood, there are multiple machines running the Cassandra cluster. In this cluster, each node is responsible for a specific range of data, which means it is storing a certain range of data. And due to the replication, which can be configured, the data set is replicated throughout the cluster, which also provides the fault tolerance. Decentralized means that there is no single point of failure. So in some systems, there is this concept of master-slave, where the writes are handled by the master and the reads are handled by the slaves. In such systems, if the master goes down, then the system may become unavailable by the time another master is up. Because Cassandra is decentralized, it has no concept of master and slave. Any node can accept the read and write. So it doesn't matter if any node goes down, the cluster is always available. That is the true power of Cassandra. Due to its distributed and decentralized architecture, Cassandra is highly available. It is also super smooth and super easy to add a new node and to remove any faulty node without impacting the cluster. And as we talked about, we can always replicate the data even to multiple data centers, which makes sure that the data is never lost. So the cluster remains highly available. Horizontally scalable means, as we talked about, it can scale to millions of nodes. As we add more nodes, as we add more machines, we get more power and more storage. Although Cassandra favors availability over consistency, but Cassandra is set to be tunable consistent, which means we can always tune or configure the consistency. The important thing is, it's the decision that we need to make in order to balance the availability and consistency. If we want more consistency, then it may impact the availability of the application or the cluster. And if we want more availability, then we'll have to trade off the consistency. So the accurate term for Cassandra is that it is tunable consistent. It's up to us how we configure this consistency. Moving on to the data model of Cassandra. Few terms that we need to understand when we talk about the data modeling in Cassandra: key space, column family, primary key, partition key, and clustering columns. In our DBMS and relational database systems, we have this schema or the database, and these databases have tables. In Cassandra, the data is organized into key spaces, and each key space serves as a top level containers for data. For simplicity, you can draw a parallel and you can say that a Cassandra key space is similar to a database schema. A column family in Cassandra is similar to a table in relational databases. Each column family has some rows and each row contains some data. Although in Cassandra, column families can have different sets of columns per row. So maybe in one row there are 3 columns and the second row would have 5 columns. In RDBMS, we cannot have that. All the rows share the same schema, they have the same columns. Coming to the primary key, we know that primary key is a unique identifier, and in Cassandra, it is used to uniquely identify a row. It can be a composite key or a single column key. Partition key is different. We don't generally find this kind of key in relational databases. In Cassandra, partition key is used to distribute the data across the cluster. Now we talked about due to the distributed architecture where in the cluster there are multiple nodes and each node can store a range of data. Now this range is decided by the partition key. Depending on the partition key of the record that we are inserting, the data will be stored in a node and the different partition key can go to different node. That's how partition key is used in Cassandra to spread the data and to store the data in a Cassandra cluster. The last thing that we need to understand is clustering columns. Clustering columns in Cassandra are used to sort the data within a partition. In relational databases, we can apply the sorting on any random column as long as we don't face the problems of indexing. In Cassandra, sorting is a design decision because when we are modeling the table, when we are modeling the data, we need to identify the sorting columns, and based on the columns that we define as clustering columns, the data will be stored on the disk in their natural order. That means data is actually stored in the sorted order on the disk. It enables Cassandra to perform efficient range queries. And this sorting is defined by the clustering columns. Moving on. Now that's how a table would look like. So you see we have this table, then this table has 2 rows, row number 1 and row number 2. Then we have the primary key which uniquely identifies a certain row. And then you have the column and its value, a kind of key value pair. Now the first row has 3 columns, column 1, column 2, column 3 with 3 values. But if you notice, second row has only 2 columns, column 1 and column 4. So that's possible in Cassandra. Each row can have different number of columns and different columns altogether. Moving on. Let's talk about why Spring and Cassandra. If you are working with Cassandra as a database and it is a Java application, then you can leverage the powerful features of Spring to integrate with Cassandra. Spring provides Spring Data Project, and under this project we have Spring Data Cassandra, which provides the integration libraries for Cassandra, and it also simplifies the data access and object mapping. Then on top of that, we can use Spring Boot, which even further simplifies the application setup and configuration. And depending on the configuration provided, it can also auto-configure the project for Cassandra. Combining Spring and Cassandra allows us to build applications that can scale horizontally to handle massive amount of data in a seamless way. Now that we have covered quite a few details about Cassandra, let's move on and set it up on our local machine.